Hello. If you take our basic parabola and make some additions, you're going to get some transformations for it. So what you need to recall is y equals x squared gives us a parabola with the shape. Now let's hone in on this one of the purple line. So remember the pattern, one along from the turning point or 0, 0, one up. Next one along 2 squared is 4, so that's 3 up. All right, next one along, 1 along, and then 5 additional ones up. And that gives us a nice curved pattern of a parabola, and the other side of that gives us the symmetrical version of the same thing. That's not very curved, but bear with me. Now, as soon as you put a number in front of the x squared, like 2, you are going to get some changes where the responding or the corresponding y is twice or 2 times x squared. So when we look on our table here, for that particular example, the corresponding y's is 9 times 2 is 18, negative 2 all squared is 4, doubled is 8, and so on. Okay, so 1 squared is 1, if we double it it's 2, 2 squared is 2, double that is 8. And so when you plot those points on a graph, what you'll notice is that the step pattern, instead of being 1 along 1 up, is actually like this. Let me show you. So at the point, I'm just going to rub all this out to show you a little bit more clearly. So for the blue one, it is 1 along, and then instead of 1 up, it's twice up here. And then 1 more along, and then instead of 3 up, it's 6 more up. So you can just use that pattern when you begin sketching. So you can certainly, do this graph, sketch this graph using a table like this. However, you can also do this graph by quick sketching it and understanding that the y's are twice as stretchy as the step pattern that I want you to start thinking about a little bit more. Okay, so our step pattern for a basic parabola or x squared graph is 1 along 1 up, next one along 3 up, next one along 5 up. Okay, when we double that, we are basically doubling these spaces to 2 up, 6 up, 10 up from there. So it's actually possible for you to go from 0, 0, which is the turning point, 1 along 2 up, 1 along 6 up, and so on. So just keep that in mind. But the other thing that's more important, or as important to notice from this note, is that the graph itself is twice as stretched or twice as skinny. So you're going to get skinnier graphs if you have a number in front of the x squared. So this one stretches up twice as high for each value of x squared because it's 2 times x squared. What I think would be awesome for you to do now is, if you understand this, you should now think about, what if you had a graph of y equals a half x squared? So I want you to plot that. I'm going to give you a hint if you're going to use points, which I think actually you should use point table form first. You're going to have some values of x, and you are going to calculate the values of y, which is a half times the x number squared. Now for the values of x, I want you to use numbers that you can halve. So instead of our classic -3, -2, 1, 0, and then 1, 2, 3, you certainly can use those numbers, because I know that you can deal with decimals or half numbers, but maybe try using these numbers here. Use x equals -8, -4, -2, 0, 2, 4, 8. So we're just using some different values of x, but it'll still give you the pattern, so that'll help you to decide that. When you've done that, tell me what it does to the graph. Does it make it much more skinnier, or does it do something else? Okay, go to work. have a break, make sure you have a break, and see what that graph looks like, and I'll put an answer for it up in the OneNote. Okay, take care, bye.